right? Try to get my eyes just right. So this ought to do the trick. Ah! My beautiful face! Clear, stop, pause! Ah!
Hey Maccy, what you up to?
I found this logo book in the library and thought, I'll draw me. But, I was going for realism, but I got abstract instead.
Well, you're off to a pretty good start. Let me see if I can help you a little bit. Let's just change this command here. All right, let's try it now.
Wow, it's perfect! A masterpiece! This logo program is pretty neat. I can make anything happen on an Apple II.
Logo is a great environment for learning how to program. It sounds like we need to go over what Logo is and how it became a key part of the computer education curriculum throughout the 80s and 90s.
Oh yeah, let's go!
Logo was a revolutionary program of its time. It gave users the ability to create art on their home computer without the need for a mouse or a drawing pad. Through Logo's simple commands, you're able to move your cursor around the screen and create drawings and graphics like magic. Many educators saw Logo as an excellent tool to tie the creative arts, mathematics, and problem-solving skills together. So let's hop into Logo on the Apple IIgs and get a sense of what millions of students used back in the 80s and 90s. So this is the Logo interface. You're given a playfield at the top of the screen, and this is where you'll be moving your cursor and creating your magnificent works of art. Down at the bottom, you have the command input. Here's where you can enter simple commands and move the cursor on the screen. And finally, you have the cursor. In Logo, this cursor is known as the Logo turtle, represented by an arrow, mainly due to the graphical limitations of the Apple II. You take control of the turtle using the commands typed at the bottom of the screen. The turtle will be our avatar in the computer world. From here, we can type commands like forward 10. You can move your turtle's pen down and start drawing, and then walk them forward 10 steps, drawing a line on the screen. And you can type in more complex commands like right 90, forward 100, right 90, forward 100. And you can get your turtle to move in a more complex path.
Ooh, let me try.
Here you go, Maccy.
Alright. Ooh. That's a neat trick I learned from this book. I found it on your desk. Mindstorms.
That's where that book went.
Oops. Sorry.
Well, let's go over Mindstorms and how it changed the landscape of computers and education. But first, we got to get this 2GS out of the way. Mindstorms, published in 1980, was written by Dr. Seymour Papert, one of the creators of Logo and a mathematician at MIT. In his book, Dr. Papert tells us his vision of future computers and how they can lead to a revolution in the world of education. He saw computers as an inevitable and essential part of everyone's lives in the future. Dr. Papert believed that through computers, the structure of how children would learn would change entirely.
So what I'm hearing from Dr. Papert is we should be playing games every day. But, how that change the way people learn?
Well, Papert was trying to solve a few problems that he noticed throughout the 60s and 70s through his research at MIT. He noticed there was a growing number of students and adults who had trouble with math or science, who labeled themselves as not a math person or not a science guy. He also saw people were afraid of exploring creative endeavors such as music or art, who simply labeled themselves as not artistically inclined or tone deaf. He believed that this way of thinking was self-limiting, preventing one from exploring math, art, or science simply because they labeled themselves as not good at it from an early age.
It's true. My art is wonderful. But I've always wanted to be a math person, too. He must have been onto something about this.
In Mindstorms, Papert proposed that computers could break what he called a math phobia epidemic. To do this, he presents the concept of teaching mathematics like one would teach a foreign language. In order to quickly learn the language, like French, one could travel to France and immerse themselves in the French language.
S squared plus B squared equals C squared.
In Mindstorms, he took this idea of learning through immersion and postulated that through computers, children could immerse themselves in a math land where one would need to use mathematics, geometry, and logic to navigate the world. When students were immersed in this math land, Dr. Papert believed that mathematics would no longer seem as foreign, but would seem like something familiar and more natural to the students. Papert also thought this technique could be used similarly for other subjects, allowing students to communicate concepts with the help of computers. Through his research, he noted that successful children were the ones that could build what he called intellectual structures. Essentially, the mental tools needed for a child to become a self-learner. Papert saw that the cause of math phobia was that children weren't given the proper mental tools to work with when introduced to math.
Math phobia. Those numbers can be scary. So I need a mental tool. What is a mental tool?
Good question, Maccy. As a young boy, Papert had an infatuation with cars, which grew into an obsession with gears. He loved creating Rube Goldberg-style machines using toy gears, playing with the mechanics and physics of how different sized gears interacted with each other. In school, he would imagine gears and simple mechanics to help him solve math problems.
I sometimes imagine a stack of pogs when I do math. Is that kind of a mental tool?
Exactly, Maccy. Gears, or in this case, pogs, are simply a mental image or an object to think with that can be used to get a better understanding of a subject. Papert thought that by giving students an object in the world of Logo to think with will be perfect to teach children about mathematics. For many people, including myself, Logo is one of my first programming experiences. I remember a feeling of magical awe as I experimented with different commands, making my turtle draw elaborate shapes or just fly across the screen as fast and as crazy as possible.
I'm an expert at that.
As a kid, Logo was super exciting. I wasn't just playing a regular video game. I was able to control what was happening on the screen and create my own graphics. In turn, this made using a computer and even computer programming seem more approachable and less intimidating to me as a kid.
Wow! So, Logo was the thing that got you into computers? Without Logo, there might not have been a Macintosh library. The darkest timeline!
It's okay, Maccy. Thankfully, in this timeline, Logo is one of the more popular pieces of educational software, sold in the 80s and 90s. Many teachers at the time knew the importance of computers, but they didn't exactly know how to get students excited about them except for playing games. Some teachers thought that computers could be integrated into students' day-to-day curriculum, having them learn reading, science, and math, but just on the computer. Software developers, like the famous MEC, made great courseware for practically every subject that helped teachers bring computers into the classroom.
For more on MEC, be sure to check out our awesome video on the history of MEC.
Many teachers at the beginning of the personal computing age, in the 1970s, saw computer programming as something to teach directly to students. These schools focused on teaching the basic programming language inside a dedicated instructional period. Instead of attempting to integrate computers into all subjects, they would segregate computer literacy into a single class just once or twice a week, the exact opposite of what Dr. Papert thought was the best way. In comes Seymour Papert's book, Mindstorms, which arrived in the hands of educators in 1980. Papert's Mindstorms provided teachers with an alternative method to teach computers in schools. Not only could the students begin to learn computer programming through Logo, but hopefully build much-needed logic and problem-solving skills. With Mindstorms, many teachers saw Logo as a novel tool that could help bolster the imagination of a new generation of students.
But in Mindstorms, I see kids playing with a giant robot with wheels. Were they using Logo to make the robot move?
The turtle was originally a half-dome shaped robot that would roll around on a giant sheet of paper. It was controlled via a teletype and a mainframe, with a large umbilical cord of wires connecting to the mainframe. While this large, clunky, but cute physical version of Logo was great for Papert's research at MIT, he knew there was a need to build a smaller, more portable version of this Logo that can run on popular microcomputers of the era. Papert's Mindstorms book proved to be a hit with educators across the globe, selling almost 500,000 copies in its first year of publication. The concepts in Papert's Mindstorms were bolstered by a second book called Turtle Geometry by Hal Abelson and Andrea DeSessa from MIT. This book provided an advanced set of examples and applications for the Logo programming language aimed at the high school and college level. Thanks to Mindstorms and Turtle Geometry, teachers sent hundreds of letters to Papert and his team at MIT, expressing how Logo was something they needed in their classrooms. Due to this unexpected reaction from the public, Seymour Papert and his fellow researchers at MIT created a small company, Logo Computer Systems Incorporated, or LCSI, in 1981, with the goal of getting Logo into the classroom. Their first product was creating a version of Logo for the Apple II, the most popular computer used in schools at that time.
Thanks to Apple's Kids Can't Wait program and Mac, Apple II computers were already in all the schools. Just waiting for all that sweet, sweet turtle gaming.
Well, that is true, Maccy. The Apple II proved to be a very popular platform with educators. But Logo wasn't made just for the Apple II computers.
Yeah, but we all know the best computer to use it on was the Apple II. So what kind of computers could Logo run on? I'd be impressed if a lowly TRS-80 would even be able to hack it.
Well, over the next few years, LCSI created versions of Logo for the Atari home computer, the Commodore, the IBM, and yes, even the TRS-80. Oh, and they released one for the Macintosh too. A few years down the line, of course. All the computer manufacturers wanted to be the next big thing in the home. And having Logo on their machines was an excellent selling point. Parents saw Logo as a way to use the computer as a learning tool, rather than the computer just being a games machine.
Oh man, but the games were so much fun. It's pretty neat Logo even came out on those Macintoshes. What kind of systems could it run on?
Logo for the Macintosh was originally developed by LCSI and Microsoft for the 128K and 512K Macs in 1986. Helping bring Logo to the next generation of machines. There were a few other notable versions of Logo created by different developers. In 1985, a version of Logo was released by Expertelligence called XpraLogo, which offered an extended feature set, bringing 3D and spherical movements to the Logo language. Additionally, a more advanced version of Logo called Object Logo was released by Hal Abelson from MIT. This version of Logo advanced the feature set even further, bringing object-oriented programming to Logo, as well as integration with MIDI and even Lego robotics integration. We can show all the features of Object Logo in a future video.
That's pretty neat. Any chance that it's demo time yet?
I think it is time for a demonstration. Let's go ahead and look at Logo programming on the Apple IIGS, which is the machine that I learned Logo on when I was younger.
Oh yeah!
All right, Maccy, are you ready to show everyone the basics of Logo?
Oh yeah, I'm the Logo expert.
To get your turtle to make his first steps, type forward, followed by a distance you want your turtle to move. So let's type forward space 80, and the turtle will move forward a distance of 80.
Okay, forward 80. Cool. Now, back 100 and now forward 9,000!
When the turtle gets to the edge of the screen, he'll automatically loop around. But now we just have to wait for the turtle to traverse 9,000 steps.
A lesson has been learned today. Never send a turtle on a fool's errand.
Let's not wait for that to happen again, Maccy. So let's get our turtle to turn. To make our turtle turn, we have to send the left and right command, followed by the degrees we want our turtle to rotate. We can chain commands together by putting a space between them, giving us the ability to make more than one move on a line. So Maccy, do you want to try demonstrating how to draw a square in the logo?
A square? Sure. That's easy. Let's see. First you gotta clear the screen. Let's see. Yes, that's a pro tip. Then forward 80, right 90, forward 80, right 90, forward 80, right 90, forward 80. Ta-da!
Nice. Nice job, Maccy. So the next important command that we need to know is the repeat command. And that does just what it says. It repeats the command that is in brackets right after it. So Maccy, do you want to create a square but now use the repeat command?
Okay, let's see. Each side of the square is forward 80, right 90, so I will repeat that 4 times. I got it. Repeat 4. Open bracket, forward 80, right 90, close the bracket.
Awesome, Maccy. Now let's go over some commands in Logo that add some color and pizzazz to your art. You can change the pen color and background to one of 6 different colors. Here's a little cheat sheet on what logo colors you can use, at least on the 2GS. To set the color of the turtle's pen, we use the command setPC space and the color number we want. To set the background color, we use a similar command setBG followed by the number that corresponds to the color we want.
Oh yeah, now this is how you make art.
And finally, let's go over how to make simple functions in Logo. So let's create a circle function, Maccy.
Oh yeah, I always forget that there isn't a circle function built in.
Luckily, we can use simple commands of forward and backward and turning to create a circle of our own. First, let's start a function called circle. To create a function, you type in the command edit space quote circle, and this will open up a blank text editor.
To circle? Are we writing a letter to the circle?
Well, functions in Logo are defined by the command to space the function name. So go ahead and move to a new line, and we can start typing the commands to move the turtle.
Okay, so to get the turtle to make a circle, from the book I read, a circle is made of 360 degrees. So if we move the turtle forward 1 step and turn him 1 degree, then we just do that 360 times. Boom, get a circle.
Good job, Maccy. Now type end at the bottom of the command and press Apple A to save it. Now run your circle command by typing circle.
Circle. Ta-da! It's beautiful. Let me see what I can make now.
And that's what Logo is all about, creatively exploring within the constraints of a computer.
Oh yeah, ready for some sweet Glitha action.
Well, you definitely learned the ins and outs of Logo, Maccy. Many classrooms throughout the 80s and early 90s used Logo as a child's first introduction to computers. The commands were simple and the results were instant. Many students, including myself, loved exploring what you could do on the computer, making crazy or even beautiful designs. In the end, Logo maybe was not the revolutionary teaching tool that Dr. Papert and his followers envisioned, but Logo did change the lives of many who were lucky enough to experience it.
That's a pretty neat story, and I'm really glad Logo got you into computers. But there's just one thing. I don't think many kids these days have even heard of Logo. What happened between then and now?
That is a good point, Maccy. As much as Dr. Papert wanted his amazing program to be integrated into all subjects, there was a disconnect between his passion for teaching computers and what teachers themselves knew how to teach. Over time, Logo became something similar to the basic programming language, something that could be taught separately with its own instruction time. Also, as computers became more graphically advanced, subject-specific computer games inspired by Logo became readily available. If a student wanted to paint a picture, they could use KidPix, which had more multimedia experiences, and you can use a mouse to draw on the screen. If the same student wanted to learn math, a few rounds of Math Blaster or Number Munchers could help their addition and multiplication skills.
Aw, I guess computers kind of outgrew Logo. It's pretty neat to be able to move a turtle around with some words you type, but I'll be the first to admit, running away from triangles is a lot more fun. Triangles!
While Logo may not be as prevalent today, its legacy still lives on. Logo initially inspired software companies to develop subject-specific software targeted at young students. And there are numerous titles that draw on the idea that computers should be an integral part of a young student's curriculum. Years later, the mega company Lego would take up the Mindstorm mantle for their product line created to get kids and teenagers interested in robotics programming.
Robots? You jumped a fold here, Miss Fox. What's with these here robots?
We'll have to save that for another time, Maccy.
Aw, so what about learning programming? How do students learn today? Are they still using boring old BASIC to teach kids how to make computer games?
It's interesting you should ask that, Maccy. There's a modern programming language out there aimed at kids called Scratch. And I think you'd really enjoy using it.
Is it kind of like Logo?
It is a lot like Logo, but teachers and programmers had a lot more time to think about the best way to teach computer programming to kids. How about you make your own episode on it?
My own episode? That would be super neato. I'll start learning Scratch pronto.
I'm sure you'll do great, Maccy. And thank you all for watching our little overview of the Logo programming language. I hope you all get to try out Logo for yourself. Links are available in the description for a web-based interpreter for the Logo language. Also, stay tuned for a future episode of Maccy Plays Scratch.
Bye everyone. We'll see you next time.
Bye everybody.